All right, so today we're talking about lesson 1.2. We're going to talk about fractions, we're going to talk about decimals, we're going to talk about percents. So first, let's identify the parts of a fraction, okay? We see this little box here. It's pointing to the 7. That is called the numerator. Okay, this other box here is pointing to the 8. That's at the bottom. That is the denominator. All right, so all numbers can be written as fractions, are also called rational numbers. We will talk about that in a little bit at the end of this chapter. All right, simplest form. This is something that some of us need a little more practice. We struggle a little bit because I think sometimes we look at fractions and we're just like, ugh, gross. But don't be grossed out. They're not that bad. All right, so simplest form is a fraction that cannot be further simplified. Further simplified, or simplified any further. It's in its most reduced form, simplest form, reduced. I'm going to write AKA reduced. Okay, so when I look at some of my examples here, I see some fractions. Don't freak out. It'll be all right. When I look at number 1, this is 8 over 20. Okay, they have a common factor. That's why I wanted to go over common factors, okay? If I'm not sure, I always take the smallest number and write the factors. So 8 is 1 times 8 and 2 times 4. Then I start with the biggest number because I'm looking for the greatest common factor. Does 8 go into 20? No, it does not. Does 4 go into 20? Yes, it does. So this is the greatest common factor of 8 and 20. So what I'm going to do in order to simplify that, I'm simply going to divide top and bottom by the greatest common factor. 8 divided by 4 is 2. 20 divided by 4 is 5. This is in its simplest form, okay? Again, I'm going to go over here to number 2. I got negative 6 over 18. Now, if I think about finding the GCF again, I'm going to go ahead and do that over here. So I always start with the smallest number, right? I want the GCF between 6 and 18. So I know 6 is 1 times 6 and also 2 times 3. Always start with the biggest number. Does 6 go into 18? Yes, it does. So 6 is my GCF. So I'm going to go ahead and divide top and bottom by 6. It doesn't change the fact that it's a negative, so the answer is still going to be negative. 6 divided by 6 is 1. 18 divided by 6 is 3. So its reduced form or simplest form is negative 1/3. I'm going to do one more example here, and then I want you guys to pause the video and try to do some on your own as well. All right, so when I look at number 3, at 21 and 27, well, 21 is the smallest number, so I'm going to write down 21 and write all the factors I know about 21. Well, I know it's 1 times 21 and 3 times 7. There are no other factors in 21. So, does 21 go into 27? No, it does not. Does 7 go into 27? No, it does not. Does 3 go into 27? Yes, it does. So 3 is the greatest common factor. So I'm going to divide my numerator and my denominator by 3 so I can reduce, and I get 7 over 9. Okay, so why don't you go ahead and pause the video and really try to do 4 through 9 and see if you get the right answers. Ooh, it's like the magic of TV. Don't you love it now? No, I'm just kidding. All right, I know where, I'm sorry. So I did 4, 5, and 6 in orange, okay? The greatest common factor in 4 was 8. So my fraction in its simplest form is negative 3 over 5. Then for number 5, my greatest common factor is 6. divide my numerator and denominator by 6, and I get my fraction in its most simplest form is negative 3 over 2. And number 6, my greatest common factor was 9, so I reduced my fraction by 9, and I got 4 over 5. Then for 7 through 9, I decided to change the color to blue, because why not? My greatest common factor was 8, so when I divide top and bottom by 8, I get 2 over 2. Number 8 was a little weird, that's why I circled it, because the only factors of 3 are 1 and 3, right? And if I divide the top by 3, I get 6. Divide the bottom by 3, I get 1. 6 over 1 is just 6. Number 9, when I divide the top and bottom by 4, which is the greatest common factor, I get negative 2 over 7. Be very careful not to lose a negative when you are doing this. Okay, hopefully you did a good job. If you did, give yourself a pat on the back. If you didn't, maybe you just need a little more practice, that's all. Don't worry, stay positive. All right, improper form, okay? I'll be honest, I prefer an improper fraction any day over a mixed number. So it's a fraction in which the denominator is larger. Not denominator. Oh my gosh, I'm so sorry. What am I doing? It's when the numerator is larger than the denominator. The numerator is larger than the denominator. All right, fantastic. That is what an improper fraction is. I do, honestly, I think they're cooler than mixed numbers. A mixed number is simply a number and a proper fraction. All right, we're going to practice converting those back and forth, okay? So for 10 to 15, we are going to take this improper fraction and write it as a mixed number. All right, so how we do that, I don't know if you guys remember how to do that, but what we want to do is we basically want to see how many times does 6 go into 19 evenly. All right, so if we think about the multiples of 6, they are 6, 12, 18, right? Well, 18 is less than 19, so I know if I went bigger, that wouldn't be it, right? And this is 6 times 1, this is 6 times 2, and this is 6 times 3. So that means that 6 goes into 19 3 whole times, right? If it's 18, then 19 minus 18 is 1, with 1 remainder, 1, 6. All right, there is some functions on your calculator. I can show you how to do that, but I think it's important just to practice this skill a little bit, okay? So when you look at number 11, you're like, all right, well, I know it's negative, it's going to stay negative. How many times does 3 go into 26? Evenly. If you think about the multiples of 3, I'm just erase what I have over here, and I'm going to start over again. Right, this is 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, 3 times 8 is 24, 3 times 9 is 27. 27 is too big. I need to go into 26 evenly. So I'm going to use this 24, which was 3 times 8. So that means 3 goes into 24 8 whole times. Oh, I have to do a fraction there. 8 whole times, right? And then to find out the remainder, you just take your numerator, 26, minus that 24. That gives me a 2. So the remainder goes on top, and whatever the denominator here is stays the same. So negative 8 and 2/3. All right, I'm going to do it again for number 12. Let's get rid of this business here. And if you ever need to pause or rewind, because sometimes I talk fast, just do so. You have all the controls at your fingertips. Okay, so now I'm like, looking at 2 and 8, 17. So I'm going to list the multiples of 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, 2 times 7 is 14, 2 times 8 is 16, 2 times 9 is 18. Well, 18, that's bigger than 17, so that's too big. We're going to use here. We know that 16 is 2 times 8. So again, 2 goes into 17 8 whole times, and then if we just simply subtract whatever the numerator is minus our number here, I have a remainder of 1. So 8 and 1 half. All right, cool beans. Now you know how I do. I do like you to practice a little bit to see if you get it. So go ahead, pause the video, go ahead and do 13, 14, and 15 and see if you can turn them into improper fractions. All right, so hopefully you did really good. 13 was 5 and 1/4, 14 was 2 and 1/3, and 15 is negative 4 and 3/8. All right, don't forget to don't lose the negatives, I meant. All right, so, and that's really like the main reason. I don't really like mixed numbers, you know, so, but it is a good skill to have, and some teachers don't feel the same way I do, so it's good that you practice it, okay? Now let's take a look at some mixed numbers that we're going to turn into improper fractions. If I can get my board to work for me. All right. So I don't really have a lot of room to write here, but I'm just going to write this over here on the side. So remember, if I have, oh, I guess it would help if I was on the pen. Oh my gosh, this silly thing. 3 and 1/5. What I do is I multiply the 5 times the 3, and then whatever that is, I add on the 1. So 5 times 3 is 15, plus 1 is 16. The denominator stays the same. Okay, that's how we do it. 3 times 7 is 21, plus 2 is 23. Now, I'm going to circle this because we often get very confused when it's a negative number, because you're probably like, 10 times -1 is -10, plus 9 is -1. But that's not what we're going to do. We know the answer is negative. Please do not multiply by that negative. You're simply taking the 10 times the 1. 10 times 1 is 10, plus 9 is 19. I put that over my negative. And the denominator stays the same. Okay, so if there's a negative, you're not multiplying that by a negative, just know that your answer is going to be negative, okay? So I would like you to do 19, 20, and 21. So pause the video and see if you got this down. All right, so take a look at my answers, see if they're the same as your answers. Hopefully they are, and hopefully you were trying. This is a lot easier, I think, than converting an improper fraction to a mixed number, but that's just my opinion. All right, so now we're going to flip the page over, and we're going to talk about converting fractions, decimals, and percents. All right, so in order to convert a fraction into a decimal, we simply divide the numerator by the denominator. Okay, when I do that, I get 0.5625. Then what I do is I move the decimal place two places to the right, okay? So the decimal place is here, I'm gonna go 2 places, so that means the decimal is gonna be between the 6 and the 2. So this is gonna be 56.25%. Okay? When we go the other way, okay, so the decimal in this case for 84 lives right here. In order to move from a percent to a decimal, we're going to move 2 places to the left, which is going to give me 0.84. Okay, in order to convert that to a fraction, because this is 80, if we would say this number, I don't know if you remember saying this is 84/100ths. Okay, I've had 84/100ths. I'm going to make a fraction with 84/100. And now I want to reduce. All right, so 4 is going to be the common factor, and we divide top and bottom by 4, and I get 21/25. Okay, so repeaters, remember decimals with a repeating digit can be written with a bar to show the repetition, right? We write the bar over the top. The denominator for these fractions is always a 9. So that's a little fun fact for you. All right, let's practice with the chart below. All right, so 9/20, right? Remember, we're going to divide top and bottom. You get 0.45. To turn it into percent, I simply move the decimal 2 places to the right. This is 45%. Now, when I come over here for the percent, I move, this decimal lives between the 5 and the percent sign because we don't write it, so it's like right there. Now you see it. We move 2 places to the left. So that gives me 0.05. Remember, this is 5/100ths, right? Because this is the tenths, that's the hundredths. 5/100ths, if I write that over 100, 5 is actually the greatest common factor. So when I reduce this, I get 1/20. All right, so now you can go either way if you're given the decimal. This is 26/100ths. So I can simply say 26/100. Well, I'm going to reduce by 2. 26 divided by 2 is 13. 100 divided by 2 is 50. So it's 13/50. If I wanted to go from decimal to percent, we simply move the decimal 2 places to the right. This gives me 26%. All right, 11/28. You're going to take your fancy calculators and you're going to divide. 11 divided by 28. There is a lot of decimals, but please only write the first 4. I'm going to put squiggly lines to show that this is not exactly equal. So 0.3929. When we turn a decimal to a percent, we just simply move 2 places. Right? So this is about 39.29%. All right, 38%. Remember, the decimal's right here. We need to move 2 places to the left to turn into a decimal. So 0.38. That's 38/100ths. 38/100. Divide by 2, right? 38 divided by 2 is 19, which is prime, over 100, which is 50. Right? So when I divide top and bottom by 2, I get 19/50. 1 1/9. All right, we need to first turn this into an improper fraction in order to find our fancy decimal here. So 9 times 1 is 9, plus 1 is 10, so this is 10/9. Remember, the denominator is a 9, so it's going to repeat. When I divide 10 divided by 9, I get 1.1 repeating. Put the little bar over the repeating. I move this decimal 2 places to the right, and that gives me 2 places. 1, 2. Remember, the repeating means there's multiple ones happening here. 1, 1, 1. That's what that means. So if I move 2 places, I get 111.1 repeating percent. That's an ugly one. That was an ugly one. Okay. So if your decimal, oh my gosh, please forgive me, I went too far. If your decimal is only 1 place, right? This is the tenths. So we can just, to turn it into a fraction, we go 7/10. And you're like, can I reduce that? And I cannot, because 7's already prime. It's finished. That's good. To turn this decimal into a percent, we simply go 1, 2 places to the right. This is 70%. All right, 4/5. When I divide 4 divided by 5, that gives me 0.8. Oh my goodness gracious, I don't know what is happening here. 0.8. Move 2 places to the right, that gives me 80%. 96%, remember we're gonna go 2 places. So it's gonna give me, oh my goodness gracious. 0.96, 96 100ths, right? Because I'm at the second decimal place. So 96 over 100, and then we reduce. What does 96 over 100 reduce to? I think they have a common factor of 4, right? If you divide top and bottom by 4, that gives you 24 over 25. All right, well, this is a toughie, right? Because now we have 1.48 is the decimal. Well, I'm going to move the decimal 2 places to right, so write the percent, so 148%. And I'm sorry, my pen is going crazy on me over here. All right, and this is 1.48 hundredths, 1 and 48 100ths. So we're going to do 148 over 100. Now I have to like convert that into a mixed number. That's just awful, but I'm going to do my best. I know that 100 goes in evenly at least one time, and then I'm going to do a little side work here, right? So we have 148 over 100. We know it goes on 1 with 48 remaining over 100, all right? So I know that 4 goes into both 48 and 100, so we're going to reduce by 4 and get 1 and 12/25. That was a tough one. And if you're like, oh my gosh, this is terrible, that was pretty tough. But I know you can do it. I believe in you, okay? Notice that this has a bar over the top, so we already know that our denominator over here is going to have a 9. So what I'm going to do to convert this into a decimal, I'm going to go 2 places to the left. So this is going to be 0.55 repeating. You can put the third 5 if you want to. It doesn't really matter. The bar just means there's infinite 5s after it. All right, so that's 55 100ths. So I'm just going to put the 5 over top. That's what I'm going to do. That's what I'm going to tell you to do, okay? If you know it's repeating, you know the denominator is a 9, just slap that 5 up there. All right, here is another one that's pretty ugly. It has a bar, so we know eventually we're going to end up with something with a 9, eventually, to start at least. We move 2 places to the right to make it a percent, so 233%. Oh, I guess I should put 0.3 with the bar on top. That's ugly. Sorry, guys. It's getting late. It's getting messy. 233. Ah, so it's my pen. Point. I just need to be patient, that's all. There we go. 233.3 repeating. Geez, Garcia, I almost missed it. Percent. All right, so that is 2 3/10. So we know it's not really a tenth because it has the bar. So how about we do 2 3/9. 2 3/9. Now that is, we can reduce this fraction here. That's not simplest, right? They have a common factor of 3, so this is 2 1/3. Those ones with the repeating decimals are really freaky. All right, so make sure you complete this. Fill out these notes, man. Take these notes. They're good for you. They'll help you. And the worksheet for the homework tonight is only one-sided, so you should be able to complete that. Note that number 21 and 24 are extra. You don't have to do those, but if you want to practice doing those with the little bar over top, have at it. All right, and then I'll check you later. Have an awesome day. If you have any questions, send me a message on Schoology. Bye.